Hi, everybody. We're continuing differential equations, and we're going to, let me just share my screen. I want to show you a sort of a definition, I guess. Now, this is actually, we actually did a problem like this. Well, we did the problem with the bank and earning money. So that's called unlimited growth, because that could just keep on going forever and growing and growing and growing. There's nothing stopping it. And when that happens, we use the differential equation y prime equals ry, which is exactly what we did use in our example. Actually, our example is a little more complicated because we had that $20 fee, whatever, but this is the essential equation. Y prime equals some constant times y itself. I want to do now another example of unlimited growth. And then I'm going to show you what limited growth. There's something called limited growth, which I'm going to show you that later. But first, let me show you another example of unlimited growth, and let's do it right now. So let me put my glasses on. If I put my glasses on, it means I'm getting serious, and we're gonna go right now. Let me switch cameras, and here we go. Okay, perfect. Okay, perfect. Let's do this. So we have here's a nice example. We have a population. And it grows 8% per year. And currently it's 5,000. What's the papers on this thing? Oh, right, the paper's getting on this. Okay. It's 5,000. And we want to let's find an equation for the population after t years. So we want to find an equation for the population after t years. Okay, so first of all, we know that y prime is equal to 0.08 y, because whatever the population is, you multiply that by 8%, and that's that annually. Now, it doesn't mean that every second it's growing 8%, but it's growing at that rate. It's growing at that annual rate. So now this is a separable differential equation, and I get dy over y equals 0.08 dt. Don't forget, this is not dy dx, this is dy dt, because we're talking about time now. Now I integrate each side, and I get ln y, absolute value, is equal to 0.08 t plus some constant. And I exponentiate each side, and this becomes y equals e to the 0.08 t times e to the c, but I'm just going to call that a. So y equals a times e to the 0.08 t, and this is my equation. We now have an equation that models the population growth. But we're not fully done yet because we don't know what a is. So let's hold the celebration off for a second, and let's find a. So to find a, we know that the current is 5,000. So we're starting now. So when t equals 0, then population equals 5,000. But population, that's what y is. So y equals 5,000. So I have 5,000 is equal to a times e to the 0. So that's just a. So a equals 5,000. So our true equation now, a true blue equation is, our true equation is y equals 5,000 e to the 0.08 t. And this is our true equation right there for this situation. A would be a general A, by the way, when I leave it this way, A is actually just the initial population, whatever it is. I'm gonna write A, usually a lot of times I write A sub zero. It's the initial population. But in this case, the initial population was 5,000. So there you go. We did it. Yay! Now I want to look at another type of growth called limited growth. So what I'm going to do is I want to share my screen just to show you the sort of definition. So sometimes when a product is heavily advertised, so the sales are going to grow really fast, but then it starts to it starts to like dwindle down. You see that with especially with fads and toys. They become a big toy, and then they kind of like dwindle down. You see it with movies. The first day or the first week, they make the zillions and zillions of people are seeing it, but then it kind of dwindles down. So that's limited growth. And excuse me, for limited growth, if the quantity grows at a rate proportional to the distance from the maximum value, in other words, it reaches some maximum value, m. So m is the most it could be. So it could be modeled with limited growth, and the differential equation is going to be y prime is k times m minus y, where k is a constant and m is the maximum that y could ever get. So in other words, instead of ky like we had before, we have k times m minus y. And it's kind of like the difference between y is where the y came from, and m is how far it is from where it's going. M minus y is how far it is from where it's going. So it's kind of another way to look at it. But let's do a problem here. So I want to go back to my pencil. Let's get some more paper here. And let's do a very, very nice, this is a very, very, very fine problem. Okay, here we go. So here's the example I want to give for limited growth. A new cell phone limited growth. A new cell phone is introduced. And as you know, when a new cell phone is introduced, there's all kinds of hoopla and everyone's going crazy and wow, it's unbelievable. Wow, new phone, blah, blah, blah. So the company estimates that they're going to sell, they estimate 200,000 phones sold eventually. After 1 month, they sold 20,000. How many will they have sold after 9 months? That's the question. So they estimate that there's going to be 200,000 phones sold eventually. After 1 month, they sold 20,000. How many will they have sold after 9 months? So first of all, the formula, as we said, is y prime for limited growth. Y prime equals k times m minus y, which in this case, y prime equals k times 200 minus y. No, I'm not writing 200,000. I'm writing just 200 because all the money, we're just going to keep all the money in terms of thousands. And so it was a new phone. So y of 0 just equals 0. because it started when we started this, there were no phones, no at the beginning, no phones were sold yet. We also know that y of one equals y of one, excuse me, equals 20. Because we said that after 1 month, they sold 20,000 phones. Now notice I'm putting time into months. Usually we put time in years, but this example is just going to keep it in months. So uh, we want to have a differential equation now, dy dt, and that's going to be equal to k times 200 minus y. And now I'm going to separate out. I get dy over 200 minus y equals k times dt, and k is just a constant. I integrate both sides, and I get the ln. Actually, in this case, I get the negative ln because there's a chain rule with that negative in front of the y, so it's going to be negative ln of 200 minus y, and again, that negative is coming from sort of like the reverse chain rule. And that's going to be equal to kt plus c. Now I want to find k and I want to find c. So how are we going to do this? Well, first, I'm going to, I think to make it a little bit simpler, I'm going to multiply both sides by -1. So I'm going to say ln of 200 minus y equals negative kt plus c. Now I did something very crazy here. Not crazy, but I kept it as a plus. I kept it as even after multiplying by negative, I kept it as a plus c because the negative just gets absorbed into the constant. The constant is some number. It could be positive, it could be negative. So it's plus c, some random constant. We'll figure out the random constant later. But I don't have to, you know, I could leave it as plus c. We call that being absorbed into the constant. Anyway, I'm going to exponentiate each side. And this is going to lead us to, and we've had something like this before. We have 200 minus y equals, I'm going to make a equals e to the negative kt times e to the c. And I'm just going to call this, I don't know, well, I use k, right? I'll just call this b. So 200 minus y equals e to the negative kt times b. Again, we have a b, we have a k, we want to figure out what they are. So let's first of all solve for y. So y is equal to, and I want to again, I'm going to keep on, I'm going to change that constant's name. Sorry about that, because I want to keep it all positive. So y is going to be equal to, I'm going to bring the y to the other side, bring that to this side. So I'm going to get y is equal to, now we call a times e to the negative kt plus 200. Uh-oh, didn't know where to stop. 200. Okay, now I wanted to find a and I want to find k. So we're gonna use the fact that y of 0 equals 0. So 0 is equal to a times e to the 0 plus 200, which means that a equals negative 200. Just solve for a, and then that gives me 200. That gives me, excuse me, y equals negative 200 e to the negative kt plus 200. And what comes next, what we have to do next is we want to find the value of k. So to find the value of k, well, I'm gonna have to go to another page. So I'm running out of paper here. So if you want to take a picture of this, or just remember this, or freeze this, whatever you want to do, take a screenshot, whatever you want. But I'm gonna have to switch the paper now. So now what we're gonna have to, excuse me, now what we're gonna have to do is we're gonna use the fact that y of 1 equals 20. So I'm gonna say 20 is equal to negative 200 e to the negative k times 1 and plus 200. And that gives me, if I subtract 200 from each side, so that gives me negative 180 equals negative 200 e to the negative k. Divide everything by negative 200, and I get e to the negative k is equal to 0.9. So if I take the ln of each side, I get ln of 0.9 equals negative k. And that gives me that k, so k is equals negative ln 0.9, and that's approximately, you get a calculator, that's 0.105. By the way, ln of 0.9 is negative, and the negative times the negative gives me the positive. Okay, so now my equation is, drumroll please, y equals negative 200 e to the negative 0.105 t plus 200. This is my, now to solve the problem that we had before, what is the, what's going to be after 9 years? So all I got to do is plug in 9 for this. So after, so y of 9 is equal to negative 200 times e to the negative 0.105 times 9 plus 200. And if I crunch this out with a calculator, this comes out to approximately 122.26 thousand phones. And now let's take just a quick reality check. After 1 month, they sold 20,000. After 9 months, they sold 120,000. But 9 times 20 is 180. So you see that that it slowed down. You see they didn't keep up the pace of the first month. They didn't keep it up. That first month they sold 20,000. If they would have continued 20,000 per month, then they would have had 180,000 at this point, but they didn't. And that's the limited growth thing. That it starts off, it shoots off fast in the beginning, and then it kind of tapers off in the end. And anything is possible to have that. So that's it. Now, what about the next video? It's going to talk about, sometimes you could have kind of limited and unlimited at the same time. In other words, I'm gonna kind of, well, and that's a new category. That's all I'm going to say. I'm not going to give away any. No, I'm not going to give away any spoilers. But we're going to look at a different situation in the next video, all on this section. Okay, everybody, it's been loads of fun, and I will see you guys next time. And I just want to say, oh, you know, I want to show my face to the camera. So we'll see how beautiful I am. There you go. Here I am. I just want to say bye, and I'll see you guys next time. Bye.